Okay, so today we're going to do the graphs of trig functions. But honestly, I mean, I'm very conscious of you're going to do a lot more of this in math analysis. You don't need to be doing like every nth detail here, right? But in Algebra 2, in my opinion, one of the things you're supposed to get out of Algebra 2 is just a common understanding of like lots of different shapes of functions. So that if you had data in whatever your job is somewhere that you graphed it, maybe you graph it by hand, you look at it and maybe you see a pattern. And the graph of the sine and the cosine are actually really common patterns. They're ones you want to know. The other four are kind of odd. They look kind of odd. But they have their importance too. But I mean, you can do those later on. We don't need to worry ourselves too much with that. I mean, I think I got them in here to show you, but we're not going to do much with them. But sine and cosine, yeah, we'll do sine and cosine. I would expect, since we're starting with a B day after the SOLs, we're just going to be, the first day will be B and then A and then B and then A. You're going to take your quiz on the 31st and you'll take a test on the 6th. Okay, that's the plan if we stick to it. So the graph of the sine function is called a sine wave. And it's called that because it kind of looks like a wave. And you can hear that not just because people are talking about math or science. I mean, it's something that even in a magazine article, somebody might make some reference to a sine wave, and they expect that you kind of understand what they're talking about. I mean, you could probably just have said wave, and you would have got the same understanding, but sine wave. So just to kind of understand, like, how do we get the graph of a sine wave? You get the graph of the sine wave. I've never been great at explaining this, and I remember when I was your age learning this in Algebra 2 trig, that they kind of called it like a wrapping function, right? And the wrapping function meant like you go to the unit circle, and at 1, 0, you start wrapping the number line around the circle like that. Okay, so the x on the number line, x is 0, and then x is pi over 6, and pi over 4, and pi over 3. So you're just marking off the number line with angles. And you could mark those angles just as easily with degrees and not radians. But most of the time you see it in radians. Okay, and then, so the x-coordinate of all of our points is going to be whatever the angle is. The y-coordinate for the sine, it'll be the y values on the unit circle. So it'll start with 0, 0, then it'll be pi over 6, 1/2, then it'll be pi over 4, root 2 over 2, right? And you're just going to graph those on a coordinate axis. So let's look at that again. So let's just fill some of these values in. So at x equals 0, the sine equals 0. What was that? I got something. At x equals 0, the sine equals 0. At x equals pi over 4, the sine equals root 2 over 2. And you can, for graphing purposes, we need to turn that into a decimal. And you don't have a calculator today, so I'm just going to have to do it myself here. And that will be, let me scratch this out because I don't know why I put that there. It's about 0.7, right? Okay, at pi over 2, the sine, the y-coordinate is 1. At 3 pi over 4, the sine is root 2 over 2. Again, about 0.7. At pi, the sine is 0. At 5 pi over 4, right now we're going down here, 5 pi over 4, so the sine is negative root 2 over 2. Which is negative 0.7. At 3 pi over 2, the sine is negative 1. And at 7 pi over 4, we got another negative root 2 over 2, which is negative 0.7. And at 2 pi, we're back to 0. So now we can graph all those points, right? We're going to start, 0 is here. What I got? I got up to 2 pi. So this is going to be pi. This is going to be, no, that's pi over 2, sorry. Okay, so this can be pi over 2. Man, what happened there? Why did that change? Oh, that's fine. I'll just do it like that. Pi over 2. And this is be pi. And this will be 3 pi over 2. And this will be 2 pi. Okay, 2 pi. Now go back to blue. Now just, and then let's see. Ooh, I could do this too. The minimum value is a -1. The maximum value is a 1. And now I can plot my points. This could be adventurous. 0, 0. At pi over 4, which would be about halfway there, we're about 0.7. At pi over 2, I'm at 1. At 3 pi over 4, about halfway in between, I'm back at 0.7. At pi, I'm at 0. Right? At 5 pi over 4, I'm at -0.7. Right? Then I'm down to -1, back to -0.7, and then back to 0. So looking at those points, do you see the wave? Do you see the shape, right? It's going like that and like that. Not a very good one, but you know, there's a wave. At least that's one wave, right? It goes from goes from 0 to a maximum value of 1, back to 0 to a minimum value of -1, and then back to 0. Right. What would happen if I kept going? If I went to values to the right of 2 pi? You know, you basically just got back to the 1, 0, right? So everything would just repeat itself. You know, same thing if I went this direction. You know, the wave is just going to keep repeating itself forever, right? Now, we didn't graph every angle. Like I didn't put in pi over 6. Pi over 6, the sine of pi over 6 is 1/2, right? That would have been about right there. And we didn't do pi over 3, then it's root 3 over 2. That's about 0.85, which is about right there. So, I mean, they would have all fit in there, but we just with the points we've got, we can basically see the shape of a sine. Okay. So, again, you don't have the calculators to look at this time, but I can show you on my calculator here. First, when you graph the sine, or when you graph trig functions, generally you're in radian mode. You know, you might have wondered why does it always default to radian mode? Because usually for graphs, you're definitely using radian mode. Usually, I like to set the window so that it's not just, you know, zoom 6, right? And I usually set it. This time, I set it from -4 pi to 4 pi for the x values, and I made the windows the increment pi. So this graph that you can see in the bottom right, it's going from -4 pi to +4 pi. And then it's got tick marks at every pi. You can't see them because the graph goes through right there. Okay, I made the y values go from -2 to 2, just so it wouldn't go on the whole up and down the whole screen. And with a resolution of 0.5. That's what these tick marks are right there. So maybe if you set the window, just you get to see what you want to see there. But you can see there's a wave. I mean, how many times does it go up and down from the left to right? Once, twice, 3 times, 4 times. Okay. So whenever a function, we know that it would keep going. If I went farther to the right or farther to the left, it would just keep going infinitely. Okay. When a function does that, it's called periodic. Right? These are periodic functions. And whenever you're trying to model something which is periodic, then somewhere you're going to have to get a trig function out of this. Usually sine or cosine. Okay, the distance from the x-axis to the top of the wave is called the amplitude. Right, just that blue line there, or going down too. In either case, it's got to be the same thing. That's called the amplitude. Right? The amplitude is whatever the number is in front of the sine of x. So since we just graphed sine x, it was 1 sine x. That's why it goes up to 1. Right? If I increase that number to 2, then it'll go 2 to 2, or negative 2 to 2, or whatever I want. Right? The period is the length. How long does it take for this pattern to repeat itself? Right? To go through 1, 0 to maximum, to 0 to minimum, and back to 0 again. How long does that take? In this case, it's 2 pi divided by 1 because it's the sine of 1x. If that wasn't a 1x, if it was a 2x, it wouldn't have the same period. So you change the period, how fast it's going up and down, by putting a number in front of the x. Right? You change the amplitude by putting a number in front of the sine. Right? So in the general form, and I'm following just along the way the book did it here, y equals a times the sine of bx. The amplitude is defined as the absolute value of a, meaning the a could be negative, right? But it wouldn't change the amplitude. The amplitude is always a positive number. What would change about the graph if a was negative? Right? When you put a negative in front of the function, what happens to the graph? It flips, right? So, we could have a sign that doesn't go up first, it goes down first, but the amplitude would still be the same, right? And then the period has a formula, right? The formula is 2 pi divided by b, right? And the b is the coefficient of x inside the function, right? That's the b, right? If it's the sine of x, then it's 2 pi over 1. That means the period is 2 pi. It'll repeat itself every 2 pi. Now, the cosine is actually pretty much the same. The cosine, we know from looking at the unit circle, it starts with a value of 1, and then it goes to root 3 over 2, and then it goes to root 2 over 2, and 1/2, and 0, and negative 1/2. Okay, well, that's what the sine did if you would have started it up here at pi over 2. 1, root 3 over 2, root 2 over 2, 1/2, 0, negative 1/2. So basically the sine and the cosine, they're going to have the same graph. It's just one's going to be shifted. And that is the difference, right? So I put on this, the sine and the cosine, and I put the sine as the first normal line, and I made the cosine a fat line. I'm not sure if we've done that before in class, but you make a line fat by scrolling all the way to the left margin and you hit enter once. And that'll make it a fat line. That way you can kind of see the difference in the graphs. So you can see that there's just a little bit of a shift in the two graphs. The cosine starts out with a value of 1, and then it goes down from there. The sine starts with a value of 0, goes up to 1, and then it goes down. So we know how shifts work. If you want something to shift to the left pi over 2, then you add sine of x plus pi over 2. Okay. So this is just the same kind of translation that we've already done with all the other functions. So if you go in your calculator, let's say that you looked at some data and you said, okay, this looks like it's a wave. Maybe it's a sine, maybe it's a cosine. I'm going to let the calculator make a function out of it. So after I've entered the data, I'm going to go to the stat calc and look in the menu. And if you notice down that menu, right, it goes down 8, 9, 10, 11, 12. There's the sine, right? And they actually don't have a cosine in there. They don't have any other trig functions in there. But they don't put both sine and cosine because they're just basically the same thing. One is just a shift of the other. So if you have to model, you're going to model with the sine because that's what you've got. Okay, the other graphs are these here: tangent, cotangent. Those are on the left, cosecant and secant. And, those are kind of odd shapes. I mean, I think you can look at a wave and think, okay, well, I think I can imagine some processes that might look like that. But I think you'd be hard-pressed to think of a process that you would think had that kind of a pattern. Okay. Now, the one difference, if you look at these here, is notice that the tangent and the cotangent, they actually repeat themselves every pi, not every 2 pi, right? The secant and the cosecant, because they're just 1 over the sine and the cosine, they've got a period of 2 pi. But the tangent and the cotangent don't, right? They repeat themselves every pi. Okay, so graph. Without a calculator, the trig functions by graphing the key points. And the thing is, this is a process. It's a fairly easy process once you get into it. Because in the end, it's not like it's a mystery. What's the shape that you're going to be drawing here, right? These shapes all look the same. I mean, you could basically, on every one of these, just sit down and draw the same sine wave and then just label it different, so that the amplitude is correct and the period is correct, and you'd be right, at least at this point. So let's see. 4 times the sine of x. So the amplitude is whatever the number is in front, or it's actually the absolute value, but that's a positive 4. So I know that my graph is going to go from negative 4 to positive 4. Right? The period is going to be 2 pi divided by whatever this number is in front of x, which is 2 pi. So I've labeled this whole thing. I know it's going to go through one period in that amount of time, right? So it'll go from 0 to, let's see, pi, to its maximum at pi over 2, back to 0, to its minimum, and back to 0. So in the calculator, they kind of emphasize that, in the book, they kind of emphasize you're graphing 5 key points, right? You're graphing the 3 zeros, and you're graphing a maximum and a minimum. And because we kind of know what the shape is we're aiming for, that should be plenty. That should be plenty to just sketch a curve now. It's kind of hard on this tablet. So there's the graph. Okay. So if it's a cosine function, then it's a little bit different. So here's y equals cosine of 4x. Right? The amplitude, again, is whatever is the coefficient of the cosine, and it's 1, because you don't see anything, it's 1. And why do I still have that as being 4? Fix. Because I copied it from the last slide, that's why. -1. -1, 2, 1. Okay, back to blue. Okay, the period, it'll be 2 pi divided by whatever that number is, the b right there. So 2 pi divided by 4 is pi over 2. So I'm going to label this thing with pi over 2 on the right. Now, in the end, the graph is still going to be mostly the same, although this is the cosine. So we know the cosine starts at 1, then it goes down to 0, then it goes down to -1, then it goes back to 0, and then it's back at 2 pi, or pi over 2 this time, it'll be back to 1. So that's one complete cosine wave. Started at 1 and ended at 1. Let's see if I can make this better. All cosines would look more or less like that, except for they just have different labeling on the axis. So try to graph 2 times the cosine of x. And you're going to have to label, the graph appropriately for whatever the amplitude and the period is. Right, so the amplitude is 2, the period is 2 pi. It's a cosine, so cosine starts at 1. Right, the x-coordinate on the unit circle at the angle of 0 is 1. And everything else is the same. It should look pretty much like the last one. Cosine. Right, try this one. F of x equals sine x. So what's the amplitude of this one? It's 1, right? Because the coefficient of sine is 1. So, am I in blue? Yeah. Amplitude equals 1, which means you can come over here and write a -1 and a 1. Okay, what is the period? 2, right? The period, right, is 2 pi divided by the coefficient of x, which is pi, which is 2. So you know it's going to go through one complete cycle from 0 to 2. Right, so this is a sine. It's going to go like that. Okay, so let me write it here. So this is 1. You could label 1/2 and 3/2. But it doesn't have a pi in it anymore. We divided it out. Okay, it's a sine. So we know that the sine should start at 0. Right, the sine's going to go up to its maximum, down to 0, down to its minimum, and back to 0. And that should look like one complete wave. Getting a little better at it. Okay, now here's 2. All right, we have a different amplitude and we have a different period. So what's the amplitude of this one? 1/2. So I can label this 1/2, -1/2, and +1/2. Okay, and the period is 1, right? 2 pi divided by 2 pi, which is 1. So that means 1. And this will be 1/2. It's a cosine. Let's see, cosine's going to, I'll write it here. 1/2. So it'll start at 1. It'll go back to 0. Then it'll be at -1. It'll go back to 0. And then back to +1. And understanding what the cosine looks like, I can sketch that in. Cosine. Thank you. Good. Okay, so frequency is 1 over the period, or it's the flip of the period. So where the period is 2 pi over b, frequency, which is a word we're all familiar with, right, in some other context, is b divided by 2 pi. Right? So the period is usually telling you some, how long is it to go through one period or one cycle, right? And so the frequency should be then how many cycles are you going to get in a certain unit of time? Like 10 per second, 5 per second. I mean, those are the kind of things that we would expect from a frequency, and that's what it is. And I introduced that just because it's in the next problem. A sound consisting of a single frequency is called a pure tone. An audiometer produces pure tones to test a person's auditory functions. Suppose an audiometer produces a pure tone with a frequency of 2,000 hertz. Hertz are cycles per second. The maximum pressure, P, produced from the pure tone is 2 millipascals. Write and graph a sine model that gives the pressure P as a function of time in seconds. Okay, so let's see. What were the two things that we used to graph sine or cosine? Amplitude and period, right? That was it. So can we tell what the amplitude is? It says the maximum pressure is 2 millipascals. Well, on the graph, the maximum is, in this case, it's 1/2, right? It's whatever that top value is on the graph. Or 1, right? Or 2, right? That's what the amplitude is telling you. It's the maximum. So in fact, in this problem, they've given us the maximum. It's that, 2. So our amplitude is 2. Right? What's the other thing that we have to know so that we can graph this thing? Period, right? So we can draw the boundaries of this thing. Okay, well the period would be 2 pi over b. We don't have that, but we do have the frequency. And the frequency is 2,000 hertz. And we know that the period equals 1 divided by the frequency, which in this problem is going to be 1 divided by 2,000 hertz. Right, so cycles per second, so this will be seconds per cycle. And that is going to be a pretty small number. Right, in this case, 1 divided by 2,000. Let me do it here. Five times 10 to the negative 4th. Okay, so let's see. 0.0005. So if I was going to draw this thing, like one cycle of this thing, I would have to go on the right side, one period is 0.0005. Its maximum and minimum are -2 and 2. And I guess the one thing that we didn't get out of this is that if we're going to write the equation, we need to know the b. Right? So if 2 pi, where can I do this? I'll do it like this. 2 pi divided by b, no, let me do it the other way. Frequency is b divided by 2 pi equals 2,000. So that means the b is 4,000 pi. So the equation that we're using here is P, capital P for pressure, equals 2 times the sine of 4,000 pi times time. So that's the model. And it should, with everything else labeled, that'll look like this. Okay, so there's our real world thing. Okay, that's in all of that was in section 14.1. Okay, now we jump to 14.2 because the rest of 14.1 is about those other 4 graphs that we don't want to do. But so far what we did, we showed, before, when we multiplied a function by a constant, we called that a stretch or a shrink. Now we're calling it the amplitude, right? But it's the same thing. And something new that we didn't have to deal with before is this concept of a period, right? None of our other functions had that, but these are periodic functions. What we didn't talk about is, what about horizontal and vertical shifts? Because that's what we did to all the other functions that we dealt with, right? We had to shift them around. And they kind of work pretty close to the same way. Like if you add a constant after the function, that should be a vertical shift. Plus means up, minus means down. Right? If you add or subtract from the variable inside the function, right, that's horizontal. Plus means left, minus means right. So we have to add those 2 things to our graphs of sine and cosine. And we already have the stretch or the shrink. The other thing that we didn't deal with is we didn't have a negative. We talked about it, but we actually didn't flip it. What happens if the A is negative? So notice what's going on in this one. We have an amplitude, right? This is going to change the period. In this case, the period will be 2 pi over 4, which is pi over 2. And then what's that plus 3 going to do to this graph? Should go up, right? After the function, that means up. So that's up. So in the book, when they talk about this, they say that the first thing you should do is draw a new center line. Okay? I've never thought of it like that, but it is a center line. If you don't shift it, the center line is the x-axis. Okay, now it's up 3. So now we're going to be dealing with, maybe I can do this with a dashed line, make it black. That's about right. So here's the new middle of the graph. Okay, let's see. The amplitude is going to be 2. So from this point, which is 3, it's going to go up 2. That'll make that 5. And down 2, that'll make that 1. Since the period is pi over 2, I'm going to label this over here as pi over 2. Right, that makes this pi over 4. And it's a sine graph, so it starts at 0, which has now been moved up 3. And then it goes to its maximum, back to 0, to its minimum, back to 0. So there's our graph. Okay, try to graph this a cosine, and what's the only shift you've got going on there? What's that plus 4 going to do? It's going to go up 4, right? Right. So this is going to be up 4. And the amplitude and the period are unchanged from, let's call it the parent function, right? The amplitude is 1, the period is 2 pi. Those things haven't changed. So I can, that's up 4, so the new center line, right, the new center line, 1, 2, 3, 4, will be...
Mr. Callahan,
yes.
can I steal Ashley for some reason? I am. I'm pointing at Ashley. I'm waving at you.
Okay, so I'm moving this thing up 4. Y equals 4, right? It's a cosine, so it should start at its maximum value of 1. Then it should go, oh, I didn't label this, 2 pi and pi. So then it should go down to 0, down to its minimum, back to 0, and up to a maximum. And that is the graph. And of course, with all these graphs, if we drew more to the left and right, it would just keep repeating itself. That's a terrible graph. Okay, now here's a horizontal shift. Now, remember the formula looks something like this. A times the cosine of b times x minus h plus k. So we don't have any vertical shift going on, but it's the way they've written this here. You know, you got to have, if there's a coefficient of x there, it's got to be factored out in front of parentheses so that you can compare this. I mean, right now we can say that the a is going to be 5. Right? Amplitude is 5. The period is going to be 2 pi divided by 2, which is pi. That's the period. And then what kind of a shift is x minus 3 pi? Minus 3 pi inside the function should mean right or left? It's to the right. Minus inside the function, minus means right. So that's a right 3 pi over 2. So, I'm drawing a little disconnected x-axis, so I can just start this thing at 3 pi. The period is only pi, so it's going to go through all of this by the time it gets back to 4 pi. Right? Its amplitude is 5, so I can label 1, 2, 3, 4, 5, down -5. It's a cosine function, so it should start at its maximum of 5 here, and then go down to 0, down to like that. So there's our 5 main points, and we can sketch a nice shaped cosine function. Something like that. I mean, in the end, all these graphs look the same, right? The only thing that's changing is your labeling. And the labeling is changing based on, what's being multiplied, what's being added and subtracted. But if you get that part of it right, then the shape of the graph should be the same. So try to graph this one. It looks like we've got what kind of a shift is the plus pi going to be inside? It should be left, right? And what about a -1 down? So see if you can sketch in a sine function, which it looks like it's got the same period and the same amplitude. It's just got those 2 shifts in it. Okay, so if this thing is shifted down, I mean, it usually goes from -1 to 1, so now it's going to go from -2 to 0. It's shifted to the left pi, so I'll start it there. the period is still 2 pi, so it should be going from negative pi to positive pi. Right? Oh, I could redraw the center line. And so this is a sine function, so it should start at 0, then now negative 1, go back, go up, go back to 0, go down, go back. So there's a nice sine wave. Okay, suppose you are riding a Ferris wheel that turns for 180 seconds. Your height h in feet above the ground at any time t can be modeled by this equation right there. Graph the height above the ground as a function of time. Okay, so what all is going on here? What is this 85 telling us? It's the amplitude, 80 amp. Okay, what is this telling us, this pi over 20? It's telling us something about the period, right? If that's not the period, you've got to do 2 pi divided by pi over 20, which is 40. That's the period. Okay, what's the minus 10 doing? Right 10. And what about the plus 90? Up. Right? So let's see. Let's draw this thing. So it's going to go, it's got an amplitude of 85 and it's shifted up 90. So I basically need this thing to go almost like to 200. Okay, if we start, it's going to shift. It's a sine function, which normally would start at 0 at 0, but it's shifted 10 to the right. So let me start that at 10. And then its period is 40. So if I add 10 plus 40, it should go through one complete cycle by the time it gets to 50. Like that. And what else? That. Okay, I'm going to draw a new center line in there. And from there we can sketch it in. Starts at 0 here. I should mark some tick marks on here. It goes up to its maximum. Goes down to 0. Goes down to its minimum. Oh, I did that wrong. What did I do wrong in that? It's up 90, not 100. So I ought to show it more like that. Okay. Stop that. Okay, so it starts here at 90. Why is that not working? And then it goes up 85. So 90, it's 175. It ought to be about right there. Then it goes back to 0. Then it goes down to about 5 feet above the ground. It's a Ferris wheel. And then it goes back to 90. So there's the height of the Ferris wheel as a function of time. Okay, what is the maximum height? If the middle line is 90, right? This is 90. And you add an amplitude of 85, right? Then what is the maximum? 90 plus 85, 175. What is the minimum? If it starts at 90 and it goes down 85, how high above the ground are you? 5 feet. That could be scary. Okay, so compare the graphs of y equals sine x and y equals negative sine x. And because you don't have your calculators, I'll do it here. I mean, what do you expect is going to be the difference between y equals sine x and y equals negative sine x? What does the negative do to the graph? It's going to flip it. So let me set this from negative 2 pi to positive 2 pi. Make this every pi over 2. And from negative 2 to 2. And then I go up here, and sine x. And on the second one, I'll make it negative sine x. And just to show how they're different, I'll make that a second one, a fat line. Graph. There's a sine function. And there is a negative sine function. So what did it do to the graph? Flipped it. That's what you expect. It just flipped it. So now it starts at 0 and then it goes down first instead of going up first. So that is a flip. Flip across x-axis. Okay. And I won't show this one just to speed this along. Cosine x and negative cosine x, what would you expect? It's a flip. Okay. Flip. What if a is less than 0? Then, oh, sorry. Basically what we said in the last two slides. If the a is less than 0, then it'll flip it across the x-axis. Does that change the amplitude? No, because it's absolute value of a, right? Doesn't change the amplitude. So, one more. Okay, what all's going on here? We've got a flip. We have a new amplitude. We're going to have a period of 2 pi divided by 2/3, which will be 3 pi. And we'll have a shift to the right 1/2. Okay, so it's shifted to the right, so it'll start. It starts here. But okay, then it's going to go 1, 2, 3, 4 to here. It's negative, so it'll have to go down first, and then back to 0, and then up, and then it's too far, and then up, and then back to 0. So there's the graph. And I think that's going to be it. That'll be it. Too long. So that's homework. Like I say, most of these things, you don't need a calculator to do this. So you're just going to hand draw. It's all about labeling the axes in the end. The graphs are going to look the same no matter what.